Hello everyone, let's talk about an easy problem today on Leetcode. Valid parenthesis, Leetcode 20. It says that given a string S containing just characters, um, open parenthesis, close parenthesis, or open braces, close curly braces, open square brackets, close square brackets, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. So now let's jump on to the examples. So for example, in this case, we have one open parenthesis and that closes with another one. So all is good. We return true. Same is true in this case. At any given point, reading the string, I think we can see all the parentheses are properly balanced. And in this case, even though we have one closing bracket and another closing bracket, but they are of different types. So that's why the string is uh, our string does not have valid parentheses. Um, so now that we have gone through the problem, let's jump into more examples, and then try to understand how we can solve this problem. Now let's look at more examples where the parentheses are properly nested or not. So in this case, we can see we open a parenthesis and then we close it. So that means these are matched. Similarly, we open two parentheses now and close one of them, but this one is still unmatched. Then we open two more parentheses and then close them. And finally, we close this open parenthesis here as well. So this means this is a valid parenthesis, and because the parentheses are properly matched or nested. Similarly, we can see another example where we open two parentheses but close only one. So this is also not properly nested. And finally, we see here that there's only one parenthesis open but two closed. So again, this is not a valid parenthesis. Now let's think about what is actually happening here. Um, so we can see when we open a parenthesis, all is good. Again, when we open, there are two parentheses open now. But when we get to the third character, the first parenthesis we close is the last one. So that means we need some data structure which is last in, first out, because we are canceling the last parenthesis open with the first parenthesis closed so far. So this is why I think a stack comes into the picture. And now let's see how we can use it. So suppose we have an expression containing braces, square bracket, then open bracket, close parenthesis, then close square bracket, and then close braces as well. So this looks like a valid string, but let's see how we can do it programmatically. So the idea is that whenever we get an open parenthesis or open type of bracket, we just push it into the stack. But as soon as we find corresponding closing bracket, we pop it out of the stack and match. If they match, then all is good. Eventually, if we encounter the situation where stack goes underflow or overflow, in that case, the string is not valid parenthesis. We will see why. And if the brackets don't match at all while popping out, that's also not a valid parenthesis. But let's now look at an example. This is a positive example. A green arrow I'm using for push and orange for pop. So when we get an open curly brace, we will actually put it into the stack. So this is called push operation. Then we again get a square bracket. Then we again push it into the stack. Then we get a open parenthesis. Then we again push it to the stack. Now comes the interesting part. We get a close parenthesis type of bracket, and as soon as we see, we actually pop the character from the stack and match whether it's actually matching to the um, close parenthesis, and the answer is yes. So we will continue. Now we get a close square bracket. That means we have another. We again pop out the character from the stack and match if the square brackets actually match. And finally, we have a closing um, closing a brace, and we again pop out the character from the stack and match, and they actually match. And now we come to the end of the stack, end of the expression, and our stack is also empty. So that means this is a valid string or valid parenthesis string. Now let's go to another example. Here what we have is like we have this expression with curly brace, square bracket, then parenthesis, and only the closing with square bracket. So we start our operation again. This time we get a square, we get a curly brace, so we will just push it to the stack. Then we get a square bracket, we push it to the stack, and finally we get a what do you say, open parenthesis, we push it to the stack, and then we get a square bracket, so closing square bracket. So that means we should pop out from the stack. Once we do, we actually see it's actually the top character, or the character that we popped out from the stack, is a is an open parenthesis which does not match the square closing bracket. So that means this is not a valid parenthesis string, and we will just return false in this case. Now let's look at this example where we have a square opening square bracket, parenthesis, then we have close parenthesis and square bracket, and then a close brace again. So in this case, what we will do is again, we get an open square bracket, push it to the stack. We get a close square bracket, sorry, open parenthesis, we push it to the stack. Then we get a close one, close parenthesis, so we pop out and see if they match. And actually, the popped value, that is open parenthesis, match with the closest parenthesis in the expression. Then we have a close square bracket, and then we again pop out from the stack and see that the popped out character is close square bracket, so they again match. And finally we have the last character, which is closing closing brace. But oh, we don't have anything in the stack now. That means we will have stack underflow, or stack underflow exception, and to that means the string is not valid. Now let's look at uh, I think the final example here, where we have a stack, and again an empty stack, and we are given the expression where we have a open brace, square bracket, and parenthesis, and closing parenthesis and square bracket. So in this case, what will happen is like we again get an open brace, we push it to the stack, we get a square bracket, we push it to the stack. Um, we have open parenthesis, we push it to the stack, and then we have a close parenthesis, and we pop out from the stack, and they actually match. And then we again get a close square bracket, and then we again map uh, to the to the popped out character from the stack, and they again match. And finally, our expression is over. But again, we have a stack with one value remaining. That means this parenthesis was never cancelled or never matched or processed. So again, this is not a valid parenthesis string. Now that we have understood the concept, let's start coding. So I think first thing we will need is a map of characters to character mapping, like mapping open and close parentheses of each type. In Java, we can create an immutable map using this static um, factory. So I think the first character maps to the second one. So we need 6 such entries because we have 3 types of brackets. Now we have that out of the way, we can create a stack of characters because we will be pushing parentheses, especially the open parentheses onto the stack. Now we can start looping onto the input string, and we can check if parentheses map contains PC. In this case, what we will do is because this is the character C, so that means this is a key, so that means this should be pushed onto the stack because keys are all the open bracket types, right? So we will just push onto the stack. But if that's not the case, in the other case, what we will do is like it's a closing parenthesis, right? So what we will do in this case is like we will first check if stack is empty, because before popping out, we should check that, otherwise we will get stack underflow exception, right? If the stack is empty, that means we should return false. Otherwise, what we will do is we will pop out the character from the stack, right? And we will get the corresponding value from the map. So what we can do is we can say parentheses map dot get open, right? Open field value. Then once we have it, what we have to do is we have to check if um, close is not equal to C. That means the parentheses don't match, so we again return false. And finally, I think we are done with the loop. Uh, Once we are done with the loop, we have to just make sure that stack is empty. That's the only thing, because if stack has some value in it, that means again the string is not valid parenthesis. Now let's try it out. Yes, so that works, and hopefully um, that was a good problem for you to learn. Thank you again. See you again soon in some other video. Thanks.